Cancer is a complex disease of the body that requires many physiological components to grow and develop. One essential component of cancer development is a process called angiogenesis, or the mechanism of creating new blood vessels. To examine this further, let's look at a common cancer known as squamous cell lung cancer. The squamous cell lung cancer begins in its lesion state, known as hyperplasia. This is considered the stage of uncontrolled growth, but not considered dangerous. Still relatively small, the cell of the cancer can rely on oxygen to diffuse across the whole lesion, allowing for more growth. Once the lesion gets to a certain size, it can no longer rely on diffusion to effectively circulate oxygen to the entire lesion. The lesion begins to experience hypoxia, which is a deficiency of oxygen to the cells. This hypoxia triggers the chain of events known as the angiogenic switch. As the lesion experiences hypoxia, it will secrete an angiogenic promoter protein called vascular endothelial growth factor, or VEGF for short. Normal cells have an even balance of promoters and inhibitors of angiogenesis. When this balance favors promoters, cancer has the ability to grow unchecked. This protein can detect the vascular permeability of the existing vasculature and bind to the epithelial receptors to encourage it to sprout new capillaries to supply oxygen to the lesion. Once the VEGF has bound to the transmembrane receptors of the epithelial cells of the vasculature, it triggers a signal transduction cascade of the cellular regulatory network. Now the stages to build the new vessels can begin. The first stage is the breakdown of the extracellular matrix between the lesion and the epithelium of the existing vessels. This is accomplished by a release of matrix metalloproteases caused by the binding of VEGF. Once the protein and the polysaccharides of the ECM are broken down, the endothelial cells of the vessels are able to move into the ECM and begin to divide and organize into new vessels. With the help of adhesion factors like integrin alpha or beta, the new vessels can stabilize and become a mature functioning blood supply for the lesion. Once this process is complete, the lesion has a blood vessel infrastructure that can meet its oxygen requirements so that it can continue to grow and invade the lung tissue. The angiogenic switch is one of the most important factors in uncontrolled cancer growth. However, this makes the cancer vulnerable to intervention at this stage. If there is an introduction of angiogenesis inhibitors, it can reset the balance and starve the lesion before it gets the chance to become a tumor.